Mike's chocolate-covered toothpicks have taken the world by storm. And by the time we're done here, you'll understand the right way to build a network now using a 3-tier architecture. And by the way, if you haven't seen the video yet, previous one on a 2-tier architecture, please watch that one first, or else this won't make much sense, because I'm going to pick up right where Mike's network left off. We set up Nike with a network that will scale pretty large in this building that he bought. As we grow our employee base and network devices that we have to plug in, all we have to do is buy more switches and connect them up here to the collapse core, aka distribution layer. Whoa, I'm getting crazy with my lines here. That guy over there, that guy over there. It's obviously, you can see this is becoming a mess, and so is Mike's business, because he's trying to pack everybody into this single building, and he's like, we got to grow. This is where Mike has reached the point of graduating to what's typically called a campus network. Now, I know when you hear the word campus, if you're like me, you're thinking, oh, like colleges, right? Colleges are a perfect example of a campus network, but usually a campus network is used to describe any network that spans multiple buildings in the same location. That's where we graduate, or could graduate, to a 3-tier model. But it's probably not going to be with the first building. Like, let's say this is Mike's original building that he moved into with all his employees, right? And inside of there, he's got that collapse core model, the 2 distribution layer switches connected to all of the access layer switches. That's all going on. So he's learned, because he had that outage, that when he builds building number 2, he's going to go with that same model. He's, maybe doesn't even have to get you back out there as a consultant, because he's figured it out. He watched you. Probably not, actually. He would contract you. You build the same model, and now we've got 2 buildings. Okay, wait a sec. How do we connect them together? Well, initially, you just do this. Da-da, da-da, da-da. You got your redundancy. You probably have your bandwidth, because those are some higher bandwidth links. So when people are accessing all the servers over here in building number 1, which has grown since Mike's initial toothpick foyer, they've got all the bandwidth that they need. And if you need more bandwidth, you just run more fiber optic cables between these guys and bundle them together into what's known as a lag interface. Cisco actually calls this Ether channel, which takes the bandwidth of multiple links and bundles them together. By the way, lag stands for link aggregation. A little more clear sounding than Ether channel, in my opinion. But there's no core layer here. As a matter of fact, we could probably even grow into a 3rd building. Obviously new, because it's a little brighter blue. These are kind of the dingy blue. They're old. So we would build that same model right here. Got our access layer switches. We're connecting everything up. Okay, so how's building number 3 going to connect? The same way. And now you're starting to realize this is getting a bit messy here, because in order to have true redundancy, we need to have these things fully meshed at that collapse core, that distribution layer. And so add 4th building in, and now we're like, oh, that's a lot of stuff, right? Actually, now it's a great time to talk about the core layer. Now, the core layer, when we're looking at network models like this, feels like it's just kind of out there. It's usually going to be in one of those buildings. You'll probably pick your main building, whatever building's the biggest or the most connected. You won't usually have just like this separate, like you'll see people draw it all the time like this. I show building number 1 with that whole little switch blob in there. Building number 2 with all the switch blobs in there. Building number 3 with the 2 layers of switch blob. And then they'll put kind of right in the middle. They'll be like, okay, and here's the core layer, which works from a logical mindset. Like, oh, I get it. I see how everything connects. But physically, if you're walking to that site, you're not just going to have this place where these 2 switches kind of sit in this water shack or something like that. Instead, one of those buildings will have those true 3 layers all in one building. Here's your access down here, right? Your distribution. And then right up top will be those 2 core switches. Everybody, as in all the distribution layers in these different buildings, here's building 4, distribution layer. Everybody will connect back to that core layer of building 1. Now you might be thinking, well, what does the core layer do? I mean, when we talked about the 2-layer model, we threw out all kinds of stuff at the distribution layer, like, routing and QoS and access control and all that kind of. Okay, so what's the core layer do? Nothing. I mean, nothing really. It's just a connection point. It's a really fast connection point. They better be some really good switches, because obviously if the true core goes down, all your buildings are disconnected and you have a disaster on your hands, right? But in terms of what are those switches doing to the data, it's just getting it from point A to point B as fast as humanly possible. Actually, the switches aren't human. As fast as ASICally possible. Application-specific integrated circuitry. That's literally as fast as those wires can transmit. It's going right through the core and getting to the buildings it belongs in. And that's it. That's the right way to build a network using a 3-tier architecture. I hope this has been informative for you, and I'd like to thank you for viewing.